All right, so it says here, Mr. Wilcox spends a full day at Gingerman Raceway testing some new tires on his Honda Civic. For 400 laps, he records his lap time in minutes. At the end of the day, he's going to plot the distribution of times, and he realizes that it follows an approximately normal distribution, is a mean of 1.84 and a standard deviation of 0.07. So remember that our lap times are being measured here in minutes. So those are going to be the units here of those measurements they've given us. All right, so let's look here at number one. So it says that Mr. Wilcox would really like his lap times to be consistently between 1.75 and 1.85 minutes. We're going to find what proportion of his laps were in this range. Now, even though we are using our calculator to help us find our answer, we are still going to begin by drawing a picture. So I'm going to go ahead and label this normal curve here with our information that we were given, our mean and our standard deviation. The mean is always in the middle, and so I can see here that 1.75 is going to be over here to the left. And 1.85, that's just on the other side of the mean, of the center. In fact, so I can fit it, I'm just going to keep my little line there in the center for 1.84. 1.85 is going to go up like this, and I'm still going to show that shaded region here. So we are trying to find what percent of the values are between those two endpoints. All right, so we're going to grab our calculator, and to do this calculation, to find that percent, we're going to start by pressing two buttons. We're going to press second, var. And I'm going to bring that over here on my screen as well. So when I press the second key, we get that little arrow up, and then when we press var, that's going to bring you into your distributions menu. Now, under distribution here, we are going to choose the second option, normal CDF. So we're going to go ahead and scroll down to select that, and then we're going to press enter. If you have a TI-83, your screen is not going to look exactly like this. So hang with me. I will speak to you here in just a moment. However, if your TI-84 here looks like mine, we are going to adjust these values to match our picture. So when it says lower, that is the leftmost side of our picture. So we are going to fill in 1.75. When it says upper, that's going to be the rightmost side of our picture. So, or the shaded region, I should say, that's going to be 1.85. Okay, look at the symbols here. We know these symbols. What is the next symbol? What does that represent? It's the mean. And so we're going to go ahead and fill in our mean was 1.84. And what is the next symbol? Standard deviation. And we know here that our standard deviation is 0.07. 0.07. Okay, now, if you had the TI-83, you are going to match your screen right now to look like mine. So it is not going to give you those options with the labels, but it is going to bring the command of normal CDF to your home screen, and then in parentheses, you are going to fill in the same pieces in the order that you see here. It's a little bit more work with the TI-83 because you have to have these memorized. You're not going to get the prompts. But it's not a huge deal. It's going to be the same setup every time, so it's always lower, upper, from the shading on your picture, followed by the mean, followed by the standard deviation. Okay, so whatever calculator version we have, now we're kind of all in the same place for how this looks. Then we need to press enter one more time. That's our answer. That would be the answer that we would have gotten from table A. Because this was shading in between, like this is actually saving us quite a bit of time because it's already done the bigger area and it subtracted the lower area. And our final answer here is that it's about 45.75% of the time. Okay, so what I'm going to do here is record here on paper, and I would like you to do this as well, exactly what the calculator work looked like. So we went to second VARS, we went to normal CDF. These were the numbers that we filled in these positions. And I'm also going to go ahead and label what each number represents. And then I'm going to follow that with our final answer. That was 0.4575. You can keep it as a decimal if you want, or you can turn this into a percent. And we can see that 45.75% of the time, his laps were between 1.75 and 1.85 minutes. Okay, we're going to look at some different scenarios. There's some different types of pictures as we saw yesterday, and so we're going to see how that will slightly change what we're typing into the calculator. So in order to beat Ida Tong, Mr. Wilcox needs to have lap times that are less than 1.72 minutes. We're going to find the proportion of laps that were less than that time. So we're going to start off the same way, still drawing a picture. And notice how we're still putting our label off to the side. And this time I'm going to go ahead and put the mean in the middle. It's not as close to the 1.72, so that's going to be over here to the left. And the question is a lesson question. So notice how now our shading is on the left. All right, so here's how it's going to look slightly different on our calculator. So we're still going to go into normal CDF, but now we are going to adjust what we're typing in for the lower end. That means like the lower limit of the shaded region here. What we're going to do is put in a really small number. And so I'm going to make it like a really big number with a negative sign in front of it. So the number that I like to put in is negative 9,999. That's like, as these four, that's so stinking small and so far away, we're for sure going to cover everything that's on this left side. This is going to be the upper end, which is the next label of our shaded region, and that is 1.72. And the last two entries are the same, 1.84 and 0.07. So let's go ahead and do that. So I'm going to do second VARS, normal CDF. And, make sure that you're pressing the negative sign. Don't do a subtraction sign. You're going to get an error if you do that. So the negative sign is right down here below the 3. When I input the negative, it's like a little bit smaller and it's a little bit raised up. So that's how you know it's there. We'll go ahead. We actually don't need to change the mean or standard deviation since we already had this typed in from the last step. We're going to go ahead, press paste, press enter, and we can see that that's only happening about 4.32% of the time. So it does not look like Mr. Wilcox is going to beat his friend very often. The other nice thing here about having the picture does two things for us. So it helps us to make sure that we're entering in the lower and the upper bounds correctly in the correct places. But we can also assess like the reasonableness of our answers. So like this one, yeah, that looks like that could be 45%. This is a smaller section here. I probably drew it a little bit too big from what it actually is. Like that could be 4%. If I was doing problem 2 and I got an answer like 95%, I could easily look at that and say, wait, what did I type in wrong? Like that's definitely not 95% that's shaded in. All right, let's take a look here at our next situation. So here we're just finding out in what proportion of the laps did it take him more than 2 minutes. All right, so we're just going to go ahead and adjust our picture. This is now going to be like a greater than picture. So 1.84 is still our mean in the center. More than 2 minutes. So we're just going to mark a 2 down there. And this time is shading to the right since it's more than 2. Okay, so now the lower limit is 2, because we're always going from left to right where the shading is in our picture. So we're starting at 2. Now the upper limit, this is now going to be going up to a really big positive number because we want to make sure that we include all of this. So I do this the same, the 9,999, just don't put a negative in front of it. We're going to make it, keep it positive. It's a really big number. We've got the same mean. We've got, hold on, the same standard deviation. Go away, parentheses. There we go. Okay, so we're going to go ahead and type that in. I'm going to go to second bars, normal CDF. Now my lower bound is 2, the upper bound, 9,999. Okay, ooh, this is not that often, so it's only about 1.11% of the time. All right, so we've looked at all 3 scenarios here for how the shading could be in our picture. Let's take a look now at number 4. So this one is now asking, what lap time is necessary for Mr. Wilcox to be in the fastest 3% of all his laps? So this is kind of like some of those questions we saw yesterday where we're going the other direction. We're given the percent of values. We're told the area of the shaded region. We're going to work backwards and try to figure out what speed produced that. All right, so because we want him to be the fastest 3%, that's going to be the 3% that are over here in the lower end. Because a lower lap time means that he's moving faster. So this is where a little question mark would be. So the question mark is, okay, how many minutes is going to be the cutoff for 3% of our laps to be at that value or less? In other words, this is representing the 3rd percentile. Okay, so there is a way that our calculator can help us work backwards, but it's a different calculator command. So we're not going to be using normal CDF. Instead, we are still going to go to our second VARS menu. I'm just going to go ahead and put the buttons there for that. And let's take a look at our menu options. We're actually just going to go one line below normal CDF. We're going to go down to option 3. So this stands for inverse norm, meaning it's doing an inverse normal calculation for us. If you think about inverse, that means going the opposite way. So we have the percentage, we want to go backwards and figure out the value that made that. Okay, so let's go ahead and press enter. Now this is going to be the same thing with the different calculators. So if you have a TI-83, hang with me for just a moment. If your screen looks like mine, the first question that it's asking for, when it says area, this is referring to the left side. It's always going to be the area to the left. Now, for us, this is fine because our shaded region is to the left of the value that we're trying to find out. So we are going to type in 0.03, okay, because we want like our percent to the left of that value is 3%. Now, if you had a picture where your shading was to the right, like if you were trying to figure out something over here on this side, you could do 1 minus the answer that you get, because the area you type in here, that's never going to represent the area to the right. It's kind of like table A, where it's always thinking about the proportion of values to the left. All right, so we're going to type in 0.03 there. We're going to go ahead and change our mean and our standard deviation to represent our problem. So only 3 things that we're entering in now instead of 4. And let's go ahead and type that in here. Yeah. Okay, You're a lucky one. You can do left, center, or right.
Okay.
Most of us, the only option we have is left. So if it looks like mine, that's the default. For you, since ours was on the left, just select left. But if you do have that different version, if it says left, center, or right for the tail, then you actually could, like, if you wanted like the 3% on the right side, instead of doing like 0.97 and subtracting it from 1, you could still do 0.03 and then just select right. Yeah, great question. Okay, so different versions of calculators. So speaking of that, if you are a TI 83 person, this is what yours is going to look like. So again, you just have to know and remember where the numbers go. You're still going to type it in the same way. So we still have area to the left, and then followed by the mean, followed by the standard deviation. So you're going to type yours in here to match that. And remember the meaning of the answer we get here. This is not a percent. We were given the percent. We're working backwards, and this is the cutoff time in minutes. That's going to put him in the top 3% of all his laps. So I would say let's maybe let's keep a few more decimals here. So let's say that it would be about like 1.708 minutes. 1.708. Okay, and we can see that this is answering the question that was being asked. So it's asking us what lap time is necessary. Well, it's got to basically, it has to be 1.708 minutes or less. And then on paper here, you probably already wrote this down, but just in case, I'm going to go ahead and copy on mine here what it looks like when we put this into our calculator. And then we have different labels here. So we've got area to the left, followed by the mean, followed by the standard deviation. Okay, so listen carefully here, because we're going to talk about there's two places where it's okay to use these calculator calculations that we just learned. The first way that you can use this is on any multiple choice question. You are not being graded or checked for any work that you show on a multiple choice problem. And this is going to save you a lot of time to get through a multiple choice question that involves a normal calculation. All right, the second place where it's a good idea, where you can use this, is to check your answer on a free response question. So the same set of steps that we looked at and talked about yesterday, so I still have them here on the board. This is our checklist for all the things we're doing with our normal calculation. These are still the steps that are going to be required for you to show on the Chapter 2 test to get full credit for this type of question. I still need to see that you can plug in the numbers correctly and get a Z score. I still want to see your two different pictures. I need to see that you understand how to use Table A and how to interpret that information. However, when you go through all those steps there, if you have some time, with like on the test, for example, if you still have some time, go ahead and take out your calculator and check it. But you will not receive full credit if you're only doing the calculator steps on free response. But definitely, you can just do the calculator steps on multiple choice.